Okay, so let's start. So good morning to all. So so let's start the artificial neural networks. So the topic is artificial neural networks. So ANN. So basically, first I think first two classes we'll discuss about what is it's all about. If you search for ANN or if you read about basic about ANN, you will understand that it's like it is a artificial intelligence step ahead, like um, modeling human brain, right? Human brain has billions of neurons. So we were trying to build up artificial intelligence or decision making systems. This happened in 1960s, early, very early only. ANN um, was shown to be very powerful in decision making in simple problems. So these days it is also widely used because of the deep neural networks, deep neural networks, and it has its basically fundamental block is neuron or artificial neural network only, but a lot of layers. So if you see, as the name states, you may think that it is kind of an artificial robot with a brain, a robot with a artificial brain, very complicated stuff. But mm, so although you may see that a deep neural network also seems to be complicated, can seem to be complicated. So okay, it has a lot of layers, input layers, and these input layers are connected to a lot of internal layers. And this is some figure you will be uh, seeing when you search about the neural networks, right? This is basically this is deep neural network. So a lot of layers, and there'll be finally you'll be getting some output layer. So this seems very complicated, but we should understand the simplicity, how it is working, what it is working, and how it is able to give good results. And a lot of applications, and there is very less number of areas where it is not used. So so you should know that this is a part of machine learning. And what kind of machine learning? We know machine learning consists of two areas, supervised and unsupervised. So there are two areas. Machine learning has basically two areas: supervised learning, supervised learning, and unsupervised learning. Right. So in supervised learning, we are training. We need to train the students. Like a teacher teaches the students each point, like cat, dog. It give a lot of examples, lot of data, and it tells the student. And right now we understand. So based on the student's decision, this properly we are training the students. If it is wrong, we are making him correct. Maybe there is small punishment or whatever, like this another kind of reinforcement learning, which is also supervised learning. So basically we're training, like training students. A teacher is teaching students in a classroom. But unsupervised is, so neural networks or artificial neural networks basically used for supervised learning. So we have to train the neurons. So basically we have flexible connections within the neurons which is trainable, so we can change the weights, depth, etc. That is supervised learning. Unsupervised means we don't need to train. Directly we give the pattern or the data to the system or the network. It definitely give us some solution based on its own understanding, pattern matching, pattern analysis kind of thing. Okay, so this is not right now we'll not be discussing about unsupervised learning. So right now we'll see what is supervised learning, and what is ANN? Today we give what overall view of ANN. What is ANN doing? What is exactly the most simplistic way of understanding neural network? So let's start with a simple example. Mm, See, right now I'm taking a very simple example, very practical. That is how to classify. How to classify is simple. I should understand, or the system should tell me or help me to understand which is a boy, which is a girl. Right. So more simple example. So I should know there should be some characteristics which distinguish like boy. For example, here we'll take example of interest. Right. Some have their hobbies or interests kind of thing. So so I'll just try to. Um, I'll just try to understand the characteristics based on their interest. For example, I'll take two examples. One is these are characteristics. So characteristics are those things or those features which tells you which one is a girl, which one is a boy, or which one is a cat, which one is a dog. Okay, so these are marked in the x and y dimensions. So x is one dimension, y is one dimension. So what is that which distinguishes boy and girl? So I'm thinking in the case of hobbies, like interest kind of thing. So here, for just understanding who is a boy or girl, I'm just using two parameters or two characteristic features. That is, one is maybe shopping. Y axis, I'll tell shopping, shopping, shopping. So I'll just see that how much this person, I don't know whether it's a girl or boy, how much this person is interested in shopping. Okay, so why I'm putting this, because I know girls are very much interested in shopping, right? So that is one of the criteria I'm checking, because I can select anything. It can be studies, it can be playing, it can be gardening, it can be anything. So I just took here shopping because that is one criteria which I have in my data, or one feature I have already in my data. So I'll put shopping in the y-axis. So what is my logic here? I feel like girls will be always in the top here. So they'll be very much interested in shopping. Not all, I cannot generalize also, but based on my experience, I'm telling this. So this is the area where girls will be there. So boys will be opposite. Boys will not like much shopping. I don't know. There may be boys who like shopping, but I'm just taking an example here. Okay. Now another criteria which is I'm taking here is, say, for example, maybe trucking. You can say trucking. So trekking means you can say adventurous sports or whatever. You can say whatever example. So that I put in the x-axis. Trekking, or you can say what I mean is adventurous sports or something. Trekking means just you go to jungle. So why I'm using this, because I know boys will be more interested in trekking. So boys will learn very high value of trekking interest. So it will be in the green area. So that is one feature which I'm checking in my data or in my input, so that I can classify the input as boy or girl. So I don't know if there are any comments. Someone is not liking my these features, shopping and trekking. Should I use something else? I can use it. Okay. So let's fine. So here now let me check the let me write the values. Right, values. Let's say x. X, as hex goes highest, like hex is maximum, I say 100%. This 100 means the person is interested in the trucking or adventure sports 100%, and 0 means he's not interested at all, is equal. And but there is also minus 100. Minus 100 means he hate that, he hate the trucking. Okay, likewise in shopping also I have y maximum means I have 100% interest in shopping. That means 100% interest in shopping means y is top, and minus 100 interest in shopping means he hates, or he or she hates the shopping. Okay, so this is my classification. Now I'll classify. Now let take my input. Let me take any person. I have a lot of persons, x, y, z, or 1, 2, 3, 200 persons, and I'm plotting them in this scale of these two features. Well, x-axis is trekking or adventurous sports, whatever you can keep, and y-axis is shopping. Right. So now, my different food, I know what is the result. I know definitely if I put the girls will be hating trekking and boys will be hating shopping. So I know all these girls will be, that means minus 100. They'll be hating trekking and will be liking shopping. So one, in my ideal case, uh, I'll be assuming that one girl will be this position on the top left, right? Because that she likes shopping, but she hates trekking. So this is one ideal girl, which is according to my assumption. But there may be other girls who don't like shopping that much and maybe like trekking a bit more. So like this, there will be a lot of cases. Some cases they may be, right, this also, this cases they maybe don't like shopping that much. So still they're at least they are hating trekking, or at least don't like trekking that much. So these are the girls. So parallelly, I'll have a lot of boys also, and who will be liking trekking very much and hating shopping. So I show boys like this. So why I show like this, because this is, I don't know, they show in biology like this: girls with a mirror, boys with a with an arrow for fighting or whatever. So okay, so these are the people who like the trekking. So these are the boys who like trekking but don't like the shopping at all. And some will be not like trekking that much, so they'll be like this, and shall be hating shopping, and like this, something like this. So these are my tentative area for the boys. The top, bottom right, because they like trekking and hate shopping, and top left will be for girls. Okay, so now the question is, how as a person, decision maker, how are you going to um, classify or divide these two groups? The best way you can see that the best way to divide these two groups is by a straight line. Okay, so if you have a straight line, you can easily divide these two groups. Say, for example, mm, I have a straight line like this, so I'll use yellow. So if I'm able to draw a line like this, the middle, okay, so that means whatever coming at the top of this line is a girl, because shopping, that is the area where shopping interest, people whose interest in shopping is accumulated, and bottom area is people who hate shopping and people who like trekking. Okay, so this is a tentative line which helps me to identify which is the area uh, of division between girls and boys. Although this is not perfect, there may be some girls interested in trekking and hate shopping, or whatever, there may be boys interested in shopping, whatever, but this is for simple. Let me put right now, you may be seeing all these are girls as data, but in reality all this will be reality this will be a points only. This will be given as your point. We don't know whether it's girl or boy. You need to decide whether they are girl or boy, something like this. Okay, all this will be a random data without much. They'll be giving x and y data only, two characteristics that you'll be given, right? Now you have to tell me which is girl, which is boy. So this line is helping me to understand um, a division point, or a border point over which girls lie or below which boys lie. Okay, so what I'll try to model this line. So this is what neural network is trying to do. It is trying to draw a line over your data. The data is personal data, and over this data it is trying to draw a line to classify a data point is girl or boy, or 1 or 0 or x or whatever, right? So this equation is what is trying to formulate. For example, this, what is a straight line, this equation. So this equation, I'll just give a snap here. Okay, so this equation of this straight line, that is what the neural network is trying to model. So what is this equation? So again, I'll just draw, this is your x, this is y, and this is your line over which your girls and boys are separated. So again you can see this is, say this is passing through origin. So you know the equation of this straight line. What is the equation of this straight line? Y minus y1 equal to m into x minus x1, right? This is a standard equation of a straight line. So here you can see y1, it passes through the origin 0 0. So what happens? Pass to origin. So y1 and x1 can be put 0. This can be 0, x1 can be 0. And what is slope of a line passing through the origin with x equal to y? We know this is exactly, if x equal to 1, y is also 1, x equal to 2, y is also 2, x equal to minus 2, y is also minus 2, and so on and so forth. So this is actually y equal to x. So this slope is equal to 1, slope is also 1. So the equation is y equal to 1 into x, 1 into x, that is y equal to x, right? So we can say the equation of the straight line is y minus x equal to 0. So this is the line which your neural network is going to give you, which is helping you to differentiate or classify between a girl and boy. So ultimately, in any complicated scenario or simple scenario, the neural network is going to classify something or divide the data into groups, two groups or three groups, any number of groups based on a straight line, or maybe a curved line on straight line, or multi-dimensional plane or whatever. Depends on this. Here we are using a two-dimensional space. We have only x and y. That is why we need a straight line to divide this data points. Suppose we have x, y, z, then we need what? Straight line won't help us. We need a plane, right? In a three-dimensional point x, y, z, we need a plane to divide the data points. And if there are x, y, z, and r or something, we need a three-dimensional structure to divide those data points. So likewise here, let's simplify. Let's take the two characteristics, that is trekking and shopping, and we need a two-dimensional structure, that is line, to classify these 2 points. Now let's take uh, now let's take an equation. What is neural network doing? Right. So neural network is trying to find the gender. I'll just write like this: gender. So gender can be boy or girl. Gender can be boy. Gender can be girl. Right. So girl, I'll say boy. Now I have to quantify it. I have to quantify. Let's say boy equal to 0 or reverse. So let me, for example, let me take boy equal to 1 and girl equal to 0. Don't mind girls. I'm just putting a random number. Don't need to be angry. So boy is one. So this boy is one. This equation x minus 5, both cases the equation is same, x minus 5. Now boy Regan, in this case boy Regan is x minus y greater than 0, less than 0. It may be greater than 0. Let's check the plot again. Let's check this plot again. This is your plot. This is x, this is y, and you have a lot of girls here, G, 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 because they like shopping, and a lot of boys here, trekking, they like trekking. Okay. Sorry. Okay. So just we need to model the equation. So we are trying to mathematically model. We can wait a bit. Will take some time to load. Okay. So we are trying to model using equation. So so this is our equation. All the girls are on top left, and now we have boys on the bottom. That's boys here. Now we can see this straight line which is dividing these two groups is this is group. So all this is the area. This line is dividing this graph into two areas. This top area. Now what is the equation of this top area? This top area is x minus y less than 0. I think. X minus y is less than 0, right? Because x value is maximum, it will go to the right of the x-axis. So that area will be x minus y greater than 0. So this x minus y greater than 0 is this area. That means this area. And x minus y less than 0 is the green area. This is area. This is x minus y less than 0. And this is x minus y greater than 0. So all these points which comes in x minus y greater than 0 are considered as boy, and all those data points which is lying on the plane lying on the area x minus y less than 0 is girl. So this is my simplified assumption. So this is what neural network is trying to do. Now let's take a new sample. Now once you're drawn this line, so you are having some prejudice. You know this prejudice. What is the prejudice? You know all these people whose points are coming on the top, x minus y um, x minus y less than 0 are girls, x minus y greater than 0 are boys. Okay. Now let's assume we have got a data point. Say a new data point is coming. Say a new data point where x value is minus 100 and y value is 100. So what is the meaning of this? So you see what is x? This is the x trekking. Y is shopping. So we can see something. This guy or this person is hating trekking. So this person is hating trekking. So the point is minus 100 is here. Point is here and somewhere here minus 100 and y equal to 100. Like shopping very much. So it will be y equal to 100. So the point is here, this point. So definitely I know this is person will be a girl. Okay, so this is one testing. So this person's point lie on the top left of top of your line, which is x minus y, x minus y equal to 0. So at the top it is x minus y less than 0. That is a girl. So now another point, I may get another point with x equal to 10 and y equal to 5. So x equal to 10 means this person likes trekking or adventure sports, but not that much. So this point is something like this. X x is 10. That means somewhat liking. And y equal to 5. He or she does like shopping also, but only 5. So y equal to 5 something. Something here. Y equal to 5. Maybe it can be anywhere. So let's say x minus y. That is something which you're interested in. X minus y. That means 10 minus 5. 10 minus equal to 5, which is 5 greater than 0. So definitely that data point or that parameters which gives x and y is more resembles a boy. So it should be a boy. So it will be placed somewhere here, right? Because we already had decision. We have made a decision line x minus y equal to 0. Okay, so your neural network is drawn a line, and based on this line and how you decide this line, that line is decided based on training. We are training the neural network so that it have that line in its mind. So it has some kind of line, and based on that line, we give some data. It is immediately classified. Oh, this is going to be a girl. This is going to be a boy. Something like that. How? Because of experience. It is shown by experience. Girls like shopping. Boys like adventure sports, and girls hate adventure sports. Boys hates shopping. Something like that. Maybe. Um, maybe it is okay. So now another point I'm giving. I can give another point. So let's take another point, that is x equal to 150. X equal to 150. That means this personality likes 150 percentage liking in gaming or trucking. So it's so much interested. And y is only 50. That means somewhat interested in shopping. So you can see x minus y is 150 minus 50. So this is 100. So this is 100. This is greater than 0. So definitely it will be classified as a bot. Okay. So ultimately, what we are trying to explain is whatever complication your problem is, it can be in images, it can be in audio signals, it can be sensor data, it can be a bank employee data, it can be communication for mobile communication, personal data, banking employee data, hospital people data, whatever your data be. If you have correct features, if you have good data to train the neural network, ultimately it's based on a straight line. In a two-dimensional environment, just a line is going to classify your data points. So the neural network is able to get or equation of a line. It is made with formulating. It is a formulating an equation of a line to divide your input data into two classes or three classes, whatever classes, right? So that is ultimately we are trying to do. We are trying to divide geometrically a group of data, right? How it is able to do, how it is able to formulate a line by training a lot of sample data. We are going to give it in so that it can understand where I should draw the line, likewise. Okay, that's part of training. So ultimately it's trying to classify the data points. Okay, now let's model it a bit better way. Okay. Now, there may be some cases. There may be some cases where in between cases also come. In between cases may come. For example, here there may be some points here and here. So although we cannot logically understand why these people also like trekking, also like shopping, but they are girls. But it also based on the data, we'll classify them as girls only, right? And there will be some data here where these boys like yeah, boys hates trekking, right? And hates shopping also. So they'll be also here, right? And there'll be some data where boys also like shopping. They also like trucking, whatever. So there'll be a lot of data. So these all things are decided by your data, which you we use to train your neural network. So right now we are going to not going to structure of neural network, but we are trying to appreciate how it is working, what is ultimately it is doing. Just drawing a line and dividing on that line. Okay, now let's see. Let's see how it works. Okay, so right now we have two inputs here. I'll call this is x and y. X and y parameters going to your model. This is your model, neural network model. This function, some kind of function. We don't know what is function. Now we have seen a function of straight line, but it can be any function, right? Now this is going to give me input. It can be a 0 or 1. It can be a 0, it can be a 1, or you can see output o. Output o, right? Now output o, again output o can be equal to f of x. Y can write like this, right? Output o is a function of x and y. So this is ultimately how you mathematically represent the neural network. And this f of x can have two values. Can be 0, it can have 1, right? So this is 0 if it is a girl. So I'll write like this: x minus y less than 0 is 1 when x minus y greater than 0. Something like this. There are two cases. So this is your mathematical representation of your neural network. The function is a straight line, which we know. This is definitely a straight line. X minus y greater than 0. So all the points above the x minus 5, x minus 5 become 0. They are termed as 0, or girls in our case. And x minus y greater than 0 is all those points below that line, x minus y equal to 0, are termed as boys. Okay. Now, what is happening inside this? What is happening inside this function? So how we are going to give an input and get the output. Now we have some samples. We need to test whether these samples are boys or girls. Now, so mathematically we can see. So we'll give x, we'll give y, and now we can say this is a function of x and y. So this final output is a function of x and y. So now we have a more or less straight line. So whatever in a two-dimensional environment, we're giving two input. So we need to have a straight line definitely. So right now, what is more or less straight line? We can say straight line equation is x plus by plus c equal to 0, right? If it is like ax plus by equal to 0, that means it's passing through origin. We know this passing through origin, right? Because x and y is 0, we have a 0. This is passing through origin, right? So let's consider this thing, ax plus by equal to 0. So what we'll see here is we have two coefficients for x and y, a for x, b for y coefficient, right? So here we need to model this x and y are the input, a and b are the coefficients. So we need two coefficients to model straight line. Let's this a become w1, weight 1, b become w2, weight 2. Okay, so this is a coefficient, this is a constants. So let's put those constants into our model. So now I can say, I can write like this, x and y are the input, so I can write f function of xy, function of xy, which is my input, is, it can be two values, can be 1, it can be 0, right? When it is 1, when your w1, now constant is w1 constant into first input plus constant w2 second weight or constant into y, when this becomes greater than 0, right? Something like this. And what happens second value, it's the classified as girl if the w1 into input, that is x, plus w2 into y is less than 0. Okay, same thing. I didn't do anything. I have made it a generalized. Instead of constant, I have w1, constant and constant 2 w2. So all these things are simple straight line equation. I'm not going for any complication. I'm just using a straight line equation and I'm just classifying my point, whether it lines the top of the straight line, bottom of the straight line. Right. Now, now all the cases may not be ideally like a straight line passing through origin. Suppose we have a data points like this. I think it may be mixed. These are the 1 point. Girls are like this, and boys may be lying here, all over the place, here. So it may not be a line always passing through the origin. So we may also expect a line which is not passing through origin. Now we can see the neural network is classifying girls and boys using the straight line. This may be say x minus y or ax plus by plus c equal to 0. New constants. It is not passing through the origin, right? So there can be a different equation. So we want to model this here. What we'll do instead of 0, what we'll do instead of generalize the case, instead of 0, we can put a constant b, right? So what is the advantage of having a constant like b? Now we can move this line all around. Now we can move this line all around. It can be any place based on the data. I can keep the value. B can be positive and negative as well, right? Okay. So now the new model. How can I write this new model? Same thing. The function of x and y. Function of x and y. It can be two options. It can be 0. Sorry, can be 1 for the boys, for the girls. Now the equation, how I model the equation? Yes, x into our w1 constant, w1 into first input plus w2 into second input greater than b. Okay, in similar case for girls, w1 into x plus w2 into y less than b, right? There are two cases. So this both are straight lines. Now I can make it better. I can make better. I can, instead of my less than b or greater than b, I can add b also to the equation of straight line. So it becomes, so I can add b here plus b here. B is a constant. I can make it plus or minus. So this is greater than 0. This is less than 0. Same thing. I didn't do any changes. I just add a constant. Now it is similar to our straight line equation, x plus by plus c equal to 0. Okay, so the top of straight line is x w1 x plus w2 y plus b greater than 0. Bottom of the straight line is w1 x plus w2 y plus b less than 0. Right. Now, let's see how it becomes in a structural way. Now I'm trying to draw structure out of this. So what kind of structure? If you take the input as one input as x, input as y, we need two weights. We need two weights w1 into x1, w2 into y, and then we need to add this together, right? And add with a constant. So for example, I'm just adding These are multiplying. So this is node and just another node for addition with B. For example, I can add another node with B. So this B is also added to this thing, right? So this is input, this is a layer, and this output is here. Output is something like this. So this is output is a function. So I can call this is again. You should note one thing. We are getting a decision. We are getting a decision that is it is greater than zero. It is less than zero. So we are checking a condition whether our function this straight line equation w1x plus w2y plus b is greater than value or less than value. So we need one more function, which is we call activating function. Activating function. So let's see how we design a function like that. Okay. So let's see how we decide that based on some value. So for that, I think in signal systems, you might have learned a function like this. What is function? You might have learned a function named something like this. Something like this. So what is the importance of this function? Can be valued from the value can x can minus infinity to plus infinity, but y maximum value of y is actually plus 1. Minimum value of y is 0, right? Here's 0 in the red line you can say. So what is this value? Middle value, it is 0.5. So what is this function doing? This function is mapping your real number domain into a value between 0 and 1, right? So what is the name of this function? Can anyone tell me? Have you heard this function? Have you I think in signal systems you might be knowing about this function. If it is 0, your function,
Sigmoid.
yeah, sigmoid. Yeah. So what is the equation of the sigmoid? 1 divided by 1 plus e raised to minus x, right? So for example, this is f of x. So what is important? Its importance is whatever whatever your real number domain, you're mapping a real number domain into two values, 1 and 0, or any value between 0 and 1, right? So mostly it is kind of, if it is middle, if the value x is 0, if x is 0, you can put this x is 0 here. You can see this 0.5. In all other values, it can be 1. So this can be, I can manipulate this function. For example, I can make it more steep like this, more steep, something like this. So what I'm doing, I am trying to have a decision output, decision variable. What is decision, 1 or 0? If 1, I am getting a boy, 0, I am getting girl. So whatever value I'm getting by inputting my characteristics x and y into the equation of straight line, I'm getting an output, whatever the equation. For example, we have an equation of straight line like this, ax plus by plus c. Okay, so this is some value, right? This is some, I'm getting some value here, right? Putting x and y into this a and b. So this a is one constant w1, so here it is w1. B is another constant w2, and x and y are the input. C is a constant we have seen, which changes the slope or the position of the line, can say intercept kind of thing. Okay, so whatever values of x and y I'll give to this a and b, or x and y, I'll get some value here. This value I can convert into 0 and 1, right? Because I just need 1. 1 is my boy, 0 is my girl. So this kind of function is called activating function. Activating function. Okay, so basically what we discussed a simple case. So all this, there are different kinds of activating function we'll discuss later. But what we are trying to do, we are trying to understand how the neural network is working. So basically, the neural network is like a simple child. We give them data points. We give the neural network some data points. Say this is some data here, and we give some other data to the neural network, and tell the neural network to, I want this data to be divided. You can draw a straight line. So it's like a small child. What it does, it is going to draw a line like this. So the neural network is going to draw a line. Yes, now it is successful, right? Because we just got a line which can differentiate our data, some characteristics of our data. Here you can see data characteristics. What are the characteristics? There are 2 points. Here this is an xy dimension. There is an x dimension, and this is a y dimension. So each of my data points have two dimensions. Has some y, some x, some y, some x. So every data has two dimensions, x and y, x and y. Here also x and y, x and y. So it needs a straight line to divide these data points. Okay, so our neural network is successful if it is able to draw this line or equation of this line. If it is going to get the equation of this line. So what do you mean by getting equation of this line? So getting the value of this what w1 and w2, w1 and w2, because our straight line equation is nothing but w1 into x plus w2 into y equal to 0, or maybe there is constant also w1 plus x plus a b constant plus b equal to 0, something like that. So what we want, we need w1, so we need w2, maybe the constant b also, right? So neural network is going to find these constants for you. How they are going to get these constants for you? By your data, the data you're training this network, right? Now let's take an example of a three-dimensional thing, how the neural network. Now we are taking a simplistic examples. Now let's take some complicated examples. Now if your data points are like this, for example, this is one set of data. Now there are some more data, something like this. Now it's not easy, now it is a bit complicated. Now how is your neural network going to classify this kind of data? Because I don't think there's a straight line which can separate these two data points of different colors, right? So it has to do something different. No, it has to use two different. One thing is let's try to draw a line like this, but still there is some points outside the line. It is misclassifying. Some girls are becoming boys, one boys. So it needs to think again. So it what it does is try to think again. Let me use two lines this time, something like this. Now it takes two lines, and now using these two lines, it tries to classify using two lines. So what we'll get? We'll get something like this, something like this. So what happens? Now it is combining more intelligence, more layers of neural networks. It's not simplistic straight line. It is combining straight lines and is dividing this plane into not in a straight line, but a combination of straight lines. Right? Now again, it can be more complicated. How? Let's see more examples, complicated examples. So if sometimes it's maybe like this, this, and some data will be like this. You have data like this here, 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 all over the place. Now it's more complicated. You don't expect neural network to do this because not a child's play to divide this one. Now we need more higher intelligence. Now we know there is some straight line which can divide like this. So it has to find a straight line like this. Then it needs to find a straight line like this, like this, like this. Still, we are able to divide the data points into using four straight lines. So what's the difference between this and first case? First case is simplistic, very simple. It needs only one layer of neuron kind of thing. But here I need more layers of neuron. We have need four separate division, four different straight lines. So we have how many weights? Four different lines means each of this lines needed W1, W2, and here W3, W4, here W5, W6, W7, W8, something like this. And we need some B also, B1, this is B1, this is B2. So we can see as the pattern, as a pattern is becoming complicated, we are not able to distinguish exactly who is a girl, who is a boy, or exactly who is a deceased person, non-deceased person, or a dog or a cat. Things become a bit more complicated. So we need more layers of neural network in this case. Okay. Now this is ultimately what this neural network is trying to do. Now this is a two-dimensional case. Let's take an example of three-dimensional case. Say for example, with the x, y, and z. X, y, and z. What happens here? Now here also we have a lot of data points. Maybe is three-dimensional. These are the red points. Now we need the green points also here. It's spread all across. So here the differentiating will be a plane. Here this we need to draw a plane which differentiate these two data points. Differentiating medium is plane, right? So we need to draw instead of straight line, it is 3D. We need a plane, right? And this plane, plane equation of plane. It's very simple. Equation of plane is ax plus by plus cz equal to 0 if it is not passing through origin. If it is passing through origin, right? If it's not passing through origin, if ax plus by plus cz plus d equal to 0 can also happen, right? That is another option. Now if it is more complicated pattern, what we'll do? If it is a more complicated pattern, we need plane also has to bend also. Sometimes the plane has to bend. How? Something like this. Something like this. Right? So this is also an equation of a plane, multiple planes combined together, like straight line. We have drawn four straight lines combined together. So here, maybe there are some reasons data is scattered all through, right? So it needs to plane to also to bend it. So the plane data points are like this. So here the data points are like, so I need a plane which is bent. Okay, so this will be a combination of two planes, right? How is combination of two planes? Maybe one plane is like this, one plane is like this, another plane is like this. So this is a combination. This is a combination of two planes. This is a combination of two planes. So the equation also will have multiple W's. So for example, equation will have a1x plus b1y plus c1z plus d equal to 0, d1 equal to 0. Again, next plane is a2x plus b2y plus c2 plus d2 equal to 0. Right? So likewise, so the things are getting complicated because the dimensions are becoming complicated. Now we have seen only a simple classification problem where I'm dividing either 0 or 1. Where 0 is a girl, 1 is a boy. So it's much simple. Suppose we may have multiple classification problem where we have one more thing, girl, boy, or animal, something like this. It can be three, it can be four. So it becomes more complicated, and we need more and more neuron layers for this thing. Okay, I think you got the crux. So any complicated neural network, even deep neural networks also works on the simple principle. You need to draw a straight line or a plane or any complicated 3D structure or any dimension n dimension structure to divide the data. So the more complex the data you're given, the more complex the dividing plane or the structure or the geometric feature or geometric um, geometric figure you'll get. So we need more layers for that. So it becomes more layers. So this is one way you decide how many layers I should use. So more structure and more technical things we'll discuss in next class. I think I'll stop it here, and I'll be happy to answer some quick questions if you have. Okay. If there's no question, you can put your roll number.